So let's fit a transformed sine function to this scatter plot over here. First of all, let's just go ahead and start by plotting y equals the sine of x on top of the scatter plot. Well, you can see that it is in fact a sine curve. It increases and decreases, but the amplitude is wrong, period is wrong, and we need to shift it. So let's replace this with y minus 0 over 1 equals the sine of x minus 0 over 1. Now, nothing there has changed because subtracting 0 doesn't change anything and dividing by 1. We're simply allowing spaces for the placeholders, if you will, for the translations and scale changes. So the first thing we want to do is draw in the horizontal sinusoidal axis. That's a horizontal line halfway between a maximum and a minimum. 80 to negative 20 is 100. So that means we need to come 50 down from 80, which is at 30. So let's draw in here the sinusoidal axis. All right. And then the y equals the sine of x. At the origin, it looks like this spot right there, where it is on the sinusoidal axis, but increasing. So that's h comma k, or this comma this. So 10, 30. If we put in a 10 here and a 30 here, and let's graph this. Now, jumps right through that spot. Great. Now we need this amplitude to be correct. It's actually right now just 1. You see that height is 10. It's just very small 1. We need it to be 50. That's vertical. Scale change, 50. Now we have the right height. Now, the last thing we need to do is get the horizontal scale change or the horizontal stretch. If we start here and go through one cycle, we get to here. That's 2 pi currently. If we don't make any horizontal scale change, that's 2 pi, or a little bit more than 6. But what we need it to be, here is one period. Let's look at the scatter plot now. Down, up, back down to here, and that's a little less than 20. Let's call it 18. We need to get it from 6 to 8, stretching it out to 18. 6 times 3 is 18, so if we change this to a 3, you're all set. And that's all there is to it, to model a sine function to a scatter plot of data.